Okay, so last night during class, or sorry, yesterday, you were looking for the Riemann sums, or the estimate of the area under the curve for the same functions as you did the other day. But this time I asked you for a midpoint sum in M8 of the function. Now there's no difference in how you set the original problem up, which is you sketch 3 to the x, which looks like so, and you put down your interval, -1 to 3, and you realize your interval is 4 units wide, and you need 8 rectangles, so your dx, delta x, delta d is not the right answer. Your delta x is equal to 1/2, or 0.5. Now the next part is the trickiest, but the trick is once you set up the first rectangle, just use that information to determine where all the next rectangles are going to start. So for a rectangle that is 0.5 wide, if I start at -1, I'm going to go to -0.5. And it may not be to scale, I know that right now. And I know I'm going to use the middle of that interval to determine the height. I have to figure out what point is in between. Well, the trick is knowing how wide it is. We know it's 0.5 wide. We know it's 0.5 wide, so the middle is going to be 0.25 in. So the middle is going to be at -0.75. Now, I don't like how tight it is right there, so I'm just going to redraw that right here. I'm just going to make sure that's right. This is -1. This is -5. -0.5, sorry. Halfway in between those two would be 0.25 units in this way, and 0.25 units in this way. And so that would be correct to be -0.75. So now you have the starting point. Finding the rest is pretty straightforward. You just put down your x value for your first rectangle, which is -0.75. And then each rectangle is going to repeat itself every 0.5 units. So the next rectangle is going to be at -0.25. I want a total of 8 rectangles, so I'm going to keep going, just adding 0.5 to the values until I get to where I want to get to. 2.5, 0.75, 1.25, 1.75, 2.25, and 2.25, yep, there it is, and 2.75. I think that's it, because I want 8 rectangles. 1, 2, 3, 4, 5, 6, 7, 8. If you need to verify it, you can verify the last rectangle as well. The last rectangle will end at 3 and start 0.5 behind that, which is at 2.5. And the midpoint of that is going to be halfway between 2.5 and 3, which is 2.75. So I've got the right answers there, so I can just go ahead and find the y values of all of those values. And those are the y values in my calculator that I got for those values there. Add it all together, they sum up to approximately 47.94. And remember that the area of the whole thing is equal to f of x times dx. Pen's not writing very well today, sorry about that. Grady got to it. So I multiply 47.94 times 0.5, and I get an approximate area. We'll say that M8 is equal to 23.97, which is a pretty good approximation. I can't tell if it underestimates or I have a hint as to how. We'll talk about that in problems 9 and 10. Okay, very similar to the last problem, except we're finding a midpoint 6. The region we have to extend across is 3 units wide. We want 6 rectangles, so delta x, or dx, is going to be equal to 1/2 again. But we're doing midpoints this time, so we have to determine where we're starting, where our height's going to be. Each rectangle is going to be 0.5 wide. So if I start at -1, I'm ending at once again, I'm not going to scale here, I'm ending the rectangle at -0.5. But the value I'm going to use to determine its height is the midpoint of that interval right there. If it's 1/2 wide, half of that is 0.25, so the midpoint is going to be at -0.75 again. and that will give me my height for my rectangle. So I'm going to set up my table of values. So I believe that these are the correct values, but I'm just going to double check by, you don't have to find all the values in between, you know they're all halfway apart, but let's just make sure I've got them right by checking the last rectangle. The last rectangle would have ended at 2 and started at 1.5, and the height would have been based on a point right in the middle of them, which is halfway between 1.5 and 2, which would have been 1.75, and that matches what I have here. So I found all those rectangles. The summation of those f of x's is 10.04, and the area equals f of x times dx, but the sum of the area, sum of the f of x's, sorry, times dx, which is 10.04, 4 times 0.5, which is equal to 5.02, so midpoint 6 would equal 5.02. Okay, the next curve is okay, so I'm going to have 5 rectangles covering an interval that's 1 unit long. So the range, the distance we're covering is 1 unit. We need 5 rectangles. So dx is 1/5, which is the same as saying 0.2. But we're going to be careful using midpoint Riemann sums. So let's look at our first rectangle, which start at 1 and end at 1.2. But what value would determine its height? The midpoint of that region, which is 1.1. That's going to determine my height of that rectangle. So when I make my table of values x and f of x, I'm going to start at 1.1, and I'm going to go up 0.2 units each time, because each rectangle is still 0.2 units wide. 1.3, 1.5, 1.7, 1.9. That's 1, 2, 3, 4, 5 rectangles. I'll verify it's the right information. The last rectangle should have started at 1.8 and gone to 2. And the height would be determined, terrible rectangle I know, will be determined by the midpoint, which is 1.9. So these values will work. And those are the y values there. The sum of all those is equal to 4.79. And each width is 0.2, so the total area equals the sum of all the f of x's times dx, which is equal to 4.79 times 0.2, which is equal to 0.95. Your number may be off from there. As long as it's in that region, depends on where you round to. There is no perfect correct answer for that value. Okay, questions 9 and 10 are really thinking questions to determine, to see if you know whether you're underestimating or overestimating, and the only way you can really do this is to graph the information. So they ask for the interval between 1 and 5 of ln of x. Well, there's 2 ways. I shouldn't say that. Ln of x dx. And if you look at a graph of ln of x dx from 1 to 5, it looks like this. Comes up sharply at 1, and curves out, and flattens out along there. So the question is, what will the trapezoid rule do for values like this? Well, what we'll do is you just start by drawing in actual trapezoids, and you don't have to draw in a lot of trapezoids. You can draw 1 or 2 to give you an idea of what's going on, because once you draw a trapezoid in, you can see that the trapezoids are going to be under the curve. So a trapezoid will underestimate, because we can see they're falling under those regions right there. Always the trickier one is the midpoint rule. And if you have your calculator, you can always run that area formula, and it will give you, we'll talk about that more when I get back. We'll give you a little more information as to what's going on. But the midpoint rule, I'll just do these 2 that I've drawn here. I'm going to draw the midpoint rule. I'll draw this one trapezoid here. Oof, there we go. And this, not trapezoid, midpoint rectangle, and one here. And the key to see what's going on is look where there's more area outside. It looks like there's more area outside the curve than inside the curve. And whether or not I could see that on my sketch, I would know that's true, because what's happening to the shape of the graph, the graph is increasing, but the slope of the graph is decreasing as time goes by. So more of it's going to get be on the outside, so the midpoint will overestimate. You'll note that for this graph, it is concave down, and this information relates to the concavity of that graph. Let's look at the next graph. So here are two representations of the graph of e to the x. And the first thing you should notice is I didn't draw them perfectly. They don't look exactly the same, but I kept the two key features on there. They're both increasing and they're both concave up. And they asked me to estimate the area between 0 and 2. So, sorry, 0 and 2. So I'm just going to do like I just did before. I'm going to estimate where 2 is. I know where 0 is. I'm just going to draw in 2 units. On the first, I'm going to draw 2 trapezoids. So I'm going to mark that here. And I'm going to mark the points on the thing. And when it's, there we go. But you can see the trapezoids are going to overestimate. And if you're not sure even with the picture you've drawn, as long as you know it's concave up, you can over-dramatize the picture. Oh, way too fancy. You can exaggerate the picture. So because I know it's concave up, if I draw it even as sharper as a curve, and then draw 2 rectangles in, two trapezoids in, I would see that it's going to be, I'm going to lose some area, so that the trapezoids are going to overestimate. And then with the midpoint formula, estimate those 2 right here. Looks to me like it's underestimating because more of the area is inside the curve, so there's going to be an underestimate. Ooh, terrible writing of underestimate. But it all has to do with the concavity of the graph. If the concavity keeps increasing, the slope keeps increasing, you'll have an underestimate on your trapezoids. Hope this was helpful. I shall see you tomorrow to continue with the review assignment. You do not have to continue the review assignment for homework. That's something we're going to work on whenever I'm not in class, and then we'll discuss them as time goes by. Bye-bye.